What's up, people? Parker Parallel here, back to talk to you about perpendiculars and distance. The other day I had a long distance to the front of the line because all these kooks getting in line. Hey, looks only.
First thing we're going to talk about is the perpendicular postulate. That says if given a line and a point not on the line, then there exists exactly one line through the point that is perpendicular to the given line. So here we have our line K and we have a point not on that line. Then there exists exactly one line through point A that I can draw. We'll call it line J. That is perpendicular to this given line K. Now, the distance between a line and a point says the distance between a line and a point not on the line is the length of the segment perpendicular to the line from the point. So this is the whole reason we just talked about the perpendicular postulate. That said that if you have a line and a point not on the line, there's only one line that you could draw through the point that's perpendicular to the given line. So if there's only one line that you can draw that's perpendicular to the given line, then that is the distance because it's the shortest length from the line to the point. Anywhere else would be farther than this perpendicular distance. So we could say that this segment, we'll call it segment AB, would be perpendicular to segment BC. And then the measure of AB is the distance from our point, point A, to our line, line BC. Now, the two lines equidistant from a third theorem says in a plane, if two lines are equidistant from a third line, then the two lines are parallel to each other. So here we have lines M, N, and P. So if we have two lines, line M and line P, and they are both the same distance from line N, then we know that line M and line P have to be parallel to each other because they're the same distance from that third line, line N. Now, distance between two parallel lines. The distance between two parallel lines is the perpendicular distance between one of the lines and any point on the other line. So, we said before that if we wanted to find the distance between a point and a line, we needed that perpendicular distance between them. It's the same thing for two parallel lines. If you have two parallel lines, you just need to find the perpendicular distance between these two lines. So if you create a perpendicular line with one of them, it's going to be perpendicular with the other by the perpendicular transversal theorem. You also then can look at these 2 points right here and find the distance between those 2 points. And that is the distance between the two lines.
Don't get wrecked on the reef. It's example time.
Now, example 1 says line T contains points at -5, 3 and 4, -6. Find the distance between line T and point P. So we are finding the distance between a line and a point not on the line. Well, we need that perpendicular distance then, like we were talking about before. So first, let's graph this. Line T contains points at -5, 3. So I go over -5 on the x-axis, up 3 on the y-axis, put a point. Line T also contains a point at 4, -6. I go over 4 on the x-axis, down -6 on the y-axis, put my other point. Draw a line through those 2 points. That's line T. Our point P is at 2, 4. So I go over 2 on the x-axis, up 4 on the y-axis, put point P. So now I need the distance from point P to our line T. And remember, the perpendicular distance is the only distance we're concerned about. Now, this is going to take several steps. I want you to just follow along, and then you'll become more familiar with how we do this in a second. So first, we're going to find the slope perpendicular to line T. So the slope perpendicular to line T means that we need to find the slope of line T and then make it the opposite reciprocal of whatever that is. So the slope of line T we find by using the slope formula, which is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, what do we plug in here? Well, how about the 2 points that line T contains? Here we have x sub 1, y sub 1, and then x sub 2, y sub 2. So we plug those into their corresponding spot in the slope formula, and now we can simplify. -6 minus 3 is going to be -9, and then 4 minus -5 is the same as 4 plus 5, which is 9. -9 over 9 simplifies to -1. That is the slope of line T. But that's not the slope perpendicular to line T. The slope perpendicular to that would be the opposite reciprocal of -1. And the opposite reciprocal of -1, opposite means you change the sign, so it's going to be positive, and the reciprocal means you flip the fraction. Well, since it's just 1, it's 1 over 1, so if you were to flip that, it's still 1. So the opposite reciprocal of -1 is +1. So we now know the perpendicular slope to line T. How is that going to help us? Well, we are now going to graph a line through P with that perpendicular slope. So if our perpendicular slope is 1, we get a line going through P that uses that perpendicular slope of 1. So from P, we're going to go up 1 over 1, put a point, up 1 over 1, put a point. Draw a line through those points, and we now have created a line that goes through P and is perpendicular to line T. The whole reason we did this is to get that perpendicular line that went through P and to get that line that went through P and was perpendicular to line T, because now we can find the distance between point P and the intersection of our perpendicular line and line T. Well, what is that point of intersection? It looks like -2, 0. So I now can find the distance between these 2 points by using the distance formula. So when using the distance formula, we need another x sub 1, y sub 1, and another x sub 2, y sub 2. So we look over here. Those have to be our point and the intersection point. So it doesn't matter which one you make x sub 1, y sub 1, and which one you make x sub 2, y sub 2, but those are our 2 points that we're finding the distance between. So we'll make our P, our point, x sub 1, y sub 1, and our intersection point over here, -2, 0, x sub 2, y sub 2. So we plug each of those into their corresponding spot in the distance formula here. We then simplify. -2 minus 2 becomes -4, and then 0 minus 4 is also -4. -4 squared is 16, -4 squared is 16. Add those together, you get 32. Now the square root of 32, we can simplify, and that becomes 4 rad 2 units. How did we simplify that? Well, the square root of 36 is the same thing as rad 16 times rad 2, and rad 16 is 4, so we get 4 rad 2. Remember to put units because we're finding the distance between the point and the line. Example 2 says find the distance between the parallel lines Q and R with equations y is equal to 2x plus 1 and y is equal to 2x plus 6. So this is the same but different. First, we want to graph these 2 lines on this coordinate plane. So line Q has the equation y is equal to 2x plus 1, which means, since it's in slope-intercept form, we have a slope of 2 and a y-intercept of 1. So we go over to 1 on our y-axis, 0, 1 on our y-axis, we put a point. That's our y-intercept. The slope is 2, which means we go up 2, right 1, put a point. Draw a line through those. That is line Q. Line R has the equation y is equal to 2x plus 6. So that means 6 is its y-intercept. So we go up to 0, 6 and put a point. That's the y-intercept. It also has a slope of 2. That's why they're parallel. So we go up 2, right 1, put a point, draw a line going through those, and that would be line R. We've graphed our 2 lines. Now to find the distance between 2 parallel lines, here's what you're going to do. First, you're going to find the slope perpendicular to Q and R. Since Q and R are parallel, they have the exact same slope. So the slope perpendicular to one will be perpendicular to the other. So how do I find the slope perpendicular to these 2 lines? Well, I need to figure out what is the opposite reciprocal of their current slope. Their current slope, we said it was 2. So what is the opposite reciprocal of 2? Well, opposite means you change the sign, so instead of being positive, it's going to be negative. And reciprocal means you flip the fraction, so instead of being 2 over 1, it's going to be 1 over 2. So the opposite reciprocal of 2 is -1/2. So that would be the perpendicular slope to these 2 lines. Next, we're going to choose a point P on line Q, then graph a line through P with that perpendicular slope. So you could technically choose this point on R as well, and you would get the same answer, but we're going to keep it on Q for right now. So to choose a point P on line Q, doesn't matter which point. I'm going to choose this one. Sure, point P at 0, 1. So this point, we are going to graph a line through this point that we just chose on line Q with our perpendicular slope. So the perpendicular slope is -1/2, which means from our point that we chose, we're going to go down 1 and to the right 2. We put a point. Down 1 to the right 2. Put a point. We then draw a line going through those points, and we have created a line that is perpendicular to lines Q and R and passes through our chosen point P. We can now find the intersection between this perpendicular line and line R. That intersection point, which is -2, 2, we can use to find the distance between these 2 points because we now have a perpendicular segment between these 2 given lines. And to find the distance between 2 parallel lines, you need that perpendicular segment. Perfect. So how do we find the distance between 2 points? The distance formula. And to use the distance formula, we need an x sub 1 and a y sub 1, and an x sub 2 and a y sub 2. It doesn't matter which one you chose to be which. You could have switched these and you would have got the same answer. So let's plug them into their corresponding spot. -2 minus 0 is going to be -2 still, and then 2 minus 1 is 1. -2 squared is 4. 1 squared is 1. 4 plus 1 is 5. And the square root of 5, and you can't break it up any further. So we just write rad 5 units is our distance between these two parallel lines, and you're done. Now example 3 says line G contains points at 4, -1 and 4, 9. Find the distance between line G and point Q at 1, 6. Okay, so this is very similar to example 1 where you have a line and a point not on the line, and we want the distance between those two. Let's start by graphing them. So line G contains these 2 points. Let's graph 4, -1. We go 4 on the x-axis, down -1 on the y-axis, put a point, and then 4, 9, we go over 4 on the x-axis, up 9 on the y-axis, put a point, and we draw a line through those. Oh, we got a vertical line. That's interesting. We also have point Q at 1, 6. So we go over 1 on the x-axis, up 6 on the y-axis, put point Q. Now we're going to proceed just like we normally would. First step is to find the slope perpendicular to line G. So line G, if we want the slope perpendicular to line G, we want the slope of line G, and then make it the opposite reciprocal of whatever that is. Which means we take our 2 points and we plug them in the slope formula. So we pick one of the points to be x of 1, y sub 1, the other one to be x of 2, y sub 2. Doesn't matter, you could have switched those, you'll get the same answer. You plug them in to the slope formula in their corresponding spot. 9 minus -1 is the same thing as 9 plus 1, so that'd be 10, and 4 minus 4 is 0. Interesting. So what's a number over 0? That's an undefined slope. That's why we got a vertical line. Remember, vertical lines have an undefined slope. Well, if the slope of line G is undefined, and we're trying to find the slope perpendicular to line G, how do we find the perpendicular slope to an undefined slope? Well, the slope here is 10 over 0, so the opposite reciprocal of 10 over 0 would just be opposite, you change the sign so it would be negative, and reciprocal, you flip the fraction, so it would be negative 0 over 10, which just simplifies to 0, right? So the perpendicular slope to line G would be a 0 slope. Now, how does that help us? Well, in step 2, we are going to graph a line through point Q with that perpendicular slope. Well, how in the world do I graph a slope of 0? Well, if you recall, a vertical line has an undefined slope, whereas a horizontal line has a 0 slope. So we're just going to draw a horizontal line going through Q and passing through line G as well. We have now created a line that is perpendicular to line G and passes through point Q. So we can find the distance between point Q here and the intersection point, which is 4, 6. So to find the distance between these 2 points, we can use the distance formula, right? We pick one of the points to be x sub 1, y sub 1, and the other one to be x sub 2, y sub 2. Doesn't matter, you could have switched those. We then plug them in their corresponding spots in the distance formula. 4 minus 1 is going to be 3. 6 minus 6 is 0. 3 squared is 9. 0 squared is still 0. The square root of 9 is 3. So your answer is 3 units. That is the distance from point Q to our line. And that makes sense, right? Because this horizontal line, we can actually count how far these are away from each other. 1, 2, 3 units. Woo! Did it.
Gnarly, bro. It's time for a you try.
Okay, this is very similar to example 2. We want to find the distance between parallel lines Q and R with these 2 equations. So let's start by graphing these 2 equations. So line Q has the equation y is equal to 5x minus 22. So we start by plotting the y-intercept at 0, negative 22. Oh, that's off the graph. Well, let's imagine this real quick. At 0, negative 22, we have a point. And then the slope is 5. So we go up 5 over 1, and we are at 1, negative 17. We go up 5 over 1, we're at 2, negative 12. We go up 5 over 1, we're at 3, negative 7. We go up 5 over 1, we're at 4, negative 2. So we draw a line through those 2 points, and now we have this line graphed on our graph. Perfect. We then graph line R with the equation y is equal to 5x plus 4. That's a little easier. We have a y-intercept of 4. So we go to 0, 4, put a point, and then the slope is again 5 because they're parallel lines. So we go up 5 over 1, and we put a point at 1, 9. Draw a line through those, and we have graphed lines Q and R. Now, if we want to find the distance between them, remember, the first thing we want to do is find the slope perpendicular to these 2 lines. So, to find the slope perpendicular to lines Q and R, we need the slope of lines Q and R. Well, we said it's 5, right? Because it's in slope-intercept form, so mx plus b. So, m is our slope, that's 5. What's the slope perpendicular to 5? That would be the opposite reciprocal of 5. Opposite means you change the sign, so it would be negative. Reciprocal means you flip the fraction, so instead of being 5 over 1, it'll be 1 over 5. So opposite reciprocal of 5 is negative 1 over 5. I then am going to choose a point P on line R. It could be on line Q. You would get the same answer either way. But I'm going to choose my point P on line R. Let's say here at 0, 4. And then I'm going to graph a line through P with this perpendicular slope. So starting at this point, I'm going to use this slope to get the rest of my line. I go down 1, right 5, and I put a point. Down 1, right 5, and I put a point. Draw a line through those points, and I have successfully graphed a line that is perpendicular to my 2 lines and goes through my given point P. Now, as you can see, this perpendicular line intersects my line Q at a given point, and that point would be 5, 3. So all I have to do now is find the distance between these 2 points of intersection, because the perpendicular distance is the distance between 2 parallel lines. So how do I find the distance between 2 points? That would be the distance formula. So I choose one of these points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. Doesn't matter which one you choose to be which, you could switch those, you get the same answer. So I plug these coordinates into their corresponding spot in the distance formula, and I simplify. What is 5 minus 0? That's 5. What's 3 minus 4? That's negative 1. What's 5 squared? That's 25. What's negative 1 squared? That's 1. What's 25 plus 1? That's 26. And what is the square root of 26? Oh, can't do that. Well, is there a perfect square that goes into 26? No. So we just leave it rad 26 units as the distance between these 2 parallel lines. And you're done. Now, example 4 says to cross the park shown below, you must choose one of 3 paths. Which path is the shortest? Explain your reasoning. So you are here and you're trying to get to this side of the park. Well, think about it this way. You are a point and the other side of the park is a line. So the distance between a point and a line, the shortest distance between a point and a line, would be the perpendicular distance. So you're looking for which path is most close to perpendicular to this side of the park and passing through your position. So let's look at this real quick. If all of these angles add up to 180 degrees to make this straight line, then 180 minus 72 minus 15 minus 25 would equal 68. So now we have all of the angles. So based on this, which path would be closest to forming a 90-degree angle with you and this side of the park? That would be path B, right? That forms an 87-degree angle right here with you and this side of the park. So you could say that path B is the shortest path to take from you to the other side of the park because it is the path that is most close to the perpendicular distance between you and the other side of the park.